Welcome to EDU World Space.
Okay, this problem we'll be talking about arc length of a vector in space. So I love this problem because it's given a different way than we're used to seeing it. So we're given the parametrized vector, or x, y, and z components. We're told that we start at the point 0, 0, 3, and that we travel 5 units in the positive direction. And we want to know, where do we end? Right? If we travel 5 units and we started at 0, 0, 3, where will we end? So we've got to kind of think about this a little more creatively and how we can figure out what our ending point will be if this is where we're beginning. So we know our formula to find arc length is given by the starting and ending points, or starting and ending t values of the magnitude of the derivative of that vector, or in other words, the square root of the sum of the squares of the derivatives of the components of that vector. So we can use that to kind of set up an equation where we're solving for something a little bit different. So what we want to do, because these a values represent these bounds represent a t value, a value of t, and we're not given a starting or a stopping value of t, right? We're giving an actual point. So what we want to do is figure out what value of t does this point represent, our starting point represent, so we at least have one of our bounds. Okay. So the easiest way to do that is probably with this y equation, because we know that y is equal to 4t, and we know that y is 0, right? So we know that our y value is 0, and y is always equal to 4t, so that can only happen when t is equal to 0. And then we just want to go ahead and check that against our other parameters. So if t is equal to 0 here, the sine of 0 is 0, so x would be 0, so that checks out. And when t is equal to 0, the cosine of 0 is 1. 3 times 1 is 3, and that checks out with our z value. So now we know our starting t value. So we can start to set up this equation. Let's do it in blue. We know our starting t value. We don't know our ending bound, or ending value of t. That's what we're actually trying to find, because that's going to clue us into where this guy will end. So that's our unknown. And we know all of the components, so we can find their derivatives and therefore their squares. The derivative of 3 sine of t is 3 cosine of t. The derivative of 4t is just 4. And the derivative of 3 cosine of t is negative 3 sine t. Remember, we're evaluating this with respect to t. And we know that we travel 5 units. We're moving 5 units in the positive direction. That's another way of saying, hey, we're trying to figure out what this ending parameter is once we've traveled an arc length of 5. So we actually know what we want L to be. We want that to be 5 units. And now we've got an equation where once we substitute everything in, we'll have one unknown. We'll have x. We know that we want this side to equal 5. So we can go ahead and start evaluating this and seeing what we can get. So we know that 5 needs to be equal to the integral from 0 to x, the square root of 9 cosine squared t plus 16 plus 9 sine squared t with respect to t, or that's equal to, I'm going to go ahead and factor out a 9 from these two terms, and we'll see why shortly. Because I know from my Pythagorean identity that cosine squared t plus sine squared t is equal to 1. So this is just equal to 9 times 1 plus 16, which is equal to the square root of 25, which is equal to 5. So I have 5 is equal to the integral from 0 to x of 5 dt. If I take the integral of 5 dt, I get 5t, and I'm going to evaluate that from 0 to x. So 5 is equal to 5x minus 5 times 0. That's going to tell me that x needs to be equal to 1. Okay, and that would be great if the question just asked me what value of t do I stop at, but I want to know specifically at what point along this vector am I going to stop at. So that now all that I'm going to do is plug my, oh, perhaps I picked a bad variable. Don't want to confuse you. So just pretend that I never chose x for this. I know. I just want this to be a little clearer and wasn't thinking 100% clearly. So instead of x, I'll just say that I used a, because I already had an equation in terms of x, and I don't want that to be unclear. There we go. So now all that I'm going to do is go back and substitute in the value that I found for t, for a, and plug that in for t. So my new point is going to be 3 sine of 1. 4 times 1 is 4. My z value was 3 cosine of 1. And that's my final answer. Oops. Thank you for watching, and I hope this helped.